This is a numerical example of Newton's method. We're going to use Newton's method to find a numerical value for the square root of 2. Alright, we'll do that by solving the equation x squared minus 2 equals 0. Alright, so we'll find a root of f of x equal x squared minus 2. We're going to start at x0 as 1.5 because we know the square root of 2 is somewhere around 1.4, so that should be a decent guess. And f of x again is x squared minus 2, which means x prime of x is 2x. Okay, so our first step is to calculate the tangent line at 1.5 and find the x-intercept of that tangent line, okay, which we've already seen how to do that. And basically the formula for the intercept is going to be x1 is x0 minus f of x0 divided by f prime of x0. Okay, so we can make up a little table of values here. The first column is n, the second column is x of n, so 1.5 is x0. The third column is f of x of n, so that's 1.5 squared minus 2, which is 0.25. And finally the third column is f prime of 3, which is, or f prime of 0, which is 2 times x0, which is 3. Okay, so with those numbers, we see that x1, which is our next, which our approximate x-intercept for the curve, is going to be 1.5 minus 0.25 divided by 3, or about 1.4166667, and so on. Okay, so it takes us a little closer to the root, but it's not exactly the square root of 2 yet. Right, so what we do now, we start with x1, and we do the same thing. We use x1 as our point of tangency, and we calculate the x-intercept for that tangent line. Okay, so here's our table of values. We have x1 is 1.41666, and so on. F of x at 1, when we calculate that out, we get 0.006944. And f prime of x1 is 2.8333, and so on. Okay, calculating out how those numbers work, we get that our x-intercept for that tangent line, which is the one intersecting the curve at x1, turns out to be x2 equal 1.4142156, okay, which is very close to the square root of 2. And we basically continue this as many iterations as we need to until the x value kind of stops changing. And we can calculate the square of x2 and discover how close it is to the square root of 2.